I will present the introduction. My background is composites. I've been working for 30 years. Before joining Plastic Omnium, I've been working for 30 years in composites, filament winding, carbon fibers, and so on. With me, Denny Boeni will, from Mitsubishi Chemical will a little bit focus on the materials, carbon fiber specifically, and the developments there, and Johan Potargent will focus on a process of key process for manufacturing components of those tanks, namely the liners. Why are we here, and why is hydrogen suddenly so important? It's just part of the European Green Deal, so there's a massive budget foreseen for developments in hydrogen fuel cell activities by the European Commission, and part of it will go to mobility application. You can see hydrogen can provide a solution for many applications where energy is needed, but specifically in the area of mobility and transportation, already today the markets are developing for fuel cell electric vehicles, passenger vehicles, light commercial vehicles, buses and trucks, heavy-duty trucks. So this is something we will see on the roads in the coming years. My company, just to give the background, I mean, traditionally Plastic Omnium is a world leader in supplying fuel systems for storing petrol, gasoline on board, and obviously these markets are declining massively. So, and why is this? Well, in view of the massive reduction of CO2, obviously the internal combustion engine using fossil fuels will play a definite much smaller role. Just to give you an idea, so by the way, my function at Plastic Omnium is business development, which I started last year. And they gave me this picture. And today our markets is what is brown and gray. Brown is gasoline, and the gray is the diesel engines. And Plastic Omnium is world leader in supplying those tank systems. And if you look at the horizon 2030, you can see that definitely those dark brown and gray are really disappearing. And we want to focus on the little 1% up there, which is the fuel cell electric vehicle. And now you can ask me why having a market share of 25% in the internal combustion engine, how can it be compensated by only 1% or market share even smaller for the fuel cell electric vehicle? And the reason obviously is because the value we add to a car is much higher. Fuel cell system and tanks, the costs are around 6,000 to 8,000 euro per vehicle, per passenger vehicle, so it's quite significant. Whereas today, extrusion blow molded tank, the costs are around 150 euros, so it's a really interesting business for us. Now, what role does composites play? I just want to show you different ways of storing gases, talking about type 1, type 2, type 3, type 4, and type 5 cylinders. For automotive application, we're focusing on type 4 cylinders, which have a thermoplastic liner, which will be the presentation by Johan later, and reinforced by carbon fiber composite. Why do we use this? Well, compared to a steel tank, simply it's much lighter. Just to give you an idea, so we have a weight saving compared to steel tanks of around 70 to 80%. And a composite tank you will have in a typical passenger vehicle will weigh around 80 kilograms already, just the tank without the hydrogen. So there is really no alternative today for composites and for carbon fiber for this application. So that's the focus. The architecture is really simple. I mean, we have a thermoplastic liner, which acts as a permeation barrier, metallic end pieces which are mounted, and composite laminate, which is applied using the filament winding process. And here really you can see the benefits of filament winding, which is a core technology. It's an automated process, very repeatable, good quality control, and relatively high productivity compared to other composites processes. it's additive manufacturing, so we're not throwing anything away. Additive manufacturing, really we're using the carbon fiber from the beginning of the bobbin to the end of the bobbin. There's no waste of material. And also there's no finishing required. Composites are not expensive because the carbon fiber is expensive. Composites are expensive because typically applications like a bicycle frame, a lot of finishing is required. Here we don't have any finishing. And we're using the raw materials as they are produced in their cheapest form. So it's really the spool which is produced in a carbon fiber plant and the resin as supplied by the resin supplier. And obviously we can use the directional properties of the fibers very well, which for a pressure vessel is very important. Just the filament winding process. Well, don't know if you can start the video. Please. Yeah, thank you. So this is just robotic filament winding. By the way, this is a robot supplied by the company MF Tech, and I've seen they also have a booth here. So here you can see the winding of the carbon fiber around the liner. The carbon fiber already contains resin. Okay, so this is not dry filament winding, it's really wet filament winding. But you can see there's no dripping of resin. Here you have the impregnation station, which will come, which is here. You will see a rotating drum, which is taking up or picking up a specific amount of resin here. You can see this black drum rotating. On this drum, you have a wet resin, and the fibers are impregnated there. And now we go to the right to the creel, where the fibers are individually tensioned. And for quality control, and then in the end you will see the spools with the tensioners. Supplied by the company Roth in Germany, a world leader in filament winding equipment also. Voila, this is a spool of carbon fiber. So it's a very straightforward process. Now, what are the challenges for us? It's definitely the cost of the hydrogen storage. The technology can only be important if the tanks can be supplied at reasonable prices. And you can see that about half of the cost of making a tank is related to the cost of the carbon fiber and other materials, the resin, the liner, so on. But in future, it will be nearly 2/3 of the costs. So we really must go down with that's my challenge we have always with Denis. It's the cost of the carbon fiber. It's such a dominant factor in this for this application. Now, what are the challenges? Obviously, well, try to use less carbon fiber, and it is possible. Here you can see a finite element analysis picture, and you can see what is red is the areas where the carbon fiber is highly stressed. And you can see, especially in the dome area, that there's a lot of blue, green, where the fiber is less stressed. So there's a potential for optimization. And the other challenge, well, for tomorrow's world, we expect a strong growth. Even those 1 to 2% might be 2 million fuel cell electric vehicles by 2030. Again, using per vehicle around 50 kilograms of carbon fiber. You can see it's a very significant amount of carbon fiber, which is around 100 times larger than the amount of carbon fiber used in the by Boeing to build Boeing 787 aircraft. So it's a really significant application for composites. And the challenges, obviously, cost reduction. And I think, Denis, you want to tell the audience what you're doing in this area. Not only the cost reduction, but also the availability of the carbon fiber, because these amounts of carbon fiber we will need in 2030. Today, there's no production capacity in place to produce this carbon fiber. And then, big challenge, and Johan will talk about the the innovative ideas of making the liner according to automotive standards. And obviously, automotive quality coming from composites, mass manufacturing, automotive quality, it's really a different world. We have to really rethink all the manufacturing process.